Good afternoon, everyone. Today, our group will be presenting on application of derivatives and integration in geoscience, Malaysian case studies. As we know, Malaysia faces important challenges in geoscience, ranging from managing natural resources to monitoring environmental changes and even predicting natural hazards. These issues are not just scientific, they affect communities, industries, and the sustainability of our environment. This is where mathematics play a crucial role. Derivatives allow us to measure rates of change, like how quickly the rivers erodes their banks or how groundwater levels fluctuate over time. Integration, on the other hand, helps us calculate accumulation, such as total rainfall in a region or the volume of sediment deposited in the river basin. By applying these mathematical tools, scientists and engineers can transform raw data into meaningful insights. In our presentation, we'll show how these concepts are applied in real Malaysian case studies, proving that mathematics is more than theory. It is a language that helps us understand and solve real-world problems. So let's begin our journey into how derivatives and integration connect number with nature and how they help us address the pressing issue in geoscience today. As you can see on the screen, we have 4 problem statements. Each of these problems highlight a real issue in Malaysian geoscience and show how mathematics through derivatives and integration can be applied to understand and solve them. Each of the problem statements will be explained by one of our group members. Number 1, total volcanic ash deposition on Mount Kinabalu after a distant eruption will be explained by the first member, Mr. Buyong Anaksap. The second one, analyzing slope stability at a road embankment in Batangkali will be explained by second member, Muhammad Danish bin Zamrul. The third one, estimating the instantaneous rate of relative sea level rise at Port Klang Selangor using tide gauge data and derivatives will be explained by our third member, Nur Zairin Natasha binti Muhammad Najib. Lastly, estimating groundwater aquifer volume in the Selangor Basin will be explained by our last group member, Haris Iskandar bin Muhammad Faizal. So let us begin with the presentation.
Hello, good day everyone. Today I will be presenting problem 1, total volcanic ash dispositions on Mount Kinabalu after a distant eruptions. Even though Malaysia does not have active volcanoes, volcanic eruption from neighboring country can still affect our environment. Volcanic ash can be transported by wind and deposited on Mount Kinabalu in Sabah. This ash may change soil chemistry, damage vegetations, and contaminate water enhancement area. In this study, the ash dispositions read in modeled using the functions a of t equals 3t squared plus 5t plus 12, where t represents time in days after the eruptions and the unit is in kilograms per hectare per day. Our goal is to calculate the total ash deposited during the first 7 days. And now, to do this, we use integration because the dispositions rate change over time. We set up the definite integral s, total s equals the integral from 0 to 7 of 3t equal plus 5t plus 12 with respect to t. Next, we integrate each term. The integral of 3t squared with respect to t is t cubed. The integral of 5 with respect to t is 5 over 2t squared. The integral of 12 with respect to t is 12t. So the antideviations become t cubed plus 5 over 2t squared plus 12t. Now we substitute the limit from 0 to 7. 7 cubed plus 5 over 2 times 7 squared plus 12 times 7. This becomes 300 and 43 plus 112 22.5 plus 84. This gives a final answer of 549.5 kilograms per hectare of volcanic ash deposited within 7 days. Okay, for student verifications and corporations, we compare our manual calculation with the GPT generate solution. Both methods use the same integration process and produce the same final answer, which is 549.5 kilogram per hectare. This confirms that the calculations is accurate and reliable. This result showed that even distant volcanic eruption can significantly affect Malaysian highland environment. Volcanic ash can enrich soil mineral but may also damage vegetation, contaminate water source, and affect tourism activity at Mount Kinabalu. Therefore, this study highlight the importance of continuous environmental monitoring and disaster preparedness in Sabah, even though Malaysia does not have active volcanoes. Volcanoes. Thank you for your attention. You may listen to next problem. Thank you.
Thank you, the mixter, for sharing the problem. So now I want to talk about analyzing slope stability at road embankment at Batang Kali, Selangor. So the focus I want to talk about is assessing slope failure risk at the Batang Kali Road embankment using the factor of safety. Basically, in derivative, engineer basically use something called the factor of safety, or we call it as FS. Think of it as a head score for a hill. If the score is above 1.0, the hill is safe. It fall below 1.0, it slides. This score depends on the slope angle, which we call it as theta. In Malaysia, our soil is mostly decomposed granite. It is quite strong when dry, but it loses its grip very quickly when the slope gets too steep or too wet. This may increase the landslide risk among the people. Now we look at the math. We have a function that calculates the factor of safety. But geoscientists don't just want to know about the score. They want to know about the rate of change. This is where the derivative comes in. When we calculate the derivative of our safety function, we found a value like minus 4.435 when we use the theta of 45 degree. The negative sign is very important. It tells us that the angle of the hill increases, the safety score decreases. The number 4.4 tells us that the speed of the risk. It shows that even a tiny change in the hill shape can cause a massive drop in safety. This is why cutting into a hill to build a road is so delicate. And now for the justification for the result. In this calculation, the calculate derivative value of minus 4.4343 is consistent with the interpretation provided in the task description, which is minus 4.435. The slight difference is due to rounding square root of 2. The negative sign is crucial as it mathematically confirms the physical observation, which is the factor of safety decreases as the slope angle becomes steeper. I've confirmed also that the confirmation that made by AI is verified and also robust and reliable for the geoscience interpretation. That's all from me. Now I will pass to my next group members.
Thank you, Danish, for the presentation just now. Now, for problem 3, I will explain how we can estimate the instantaneous rate of relative sea level rise at Port Klang, Selangor using tide gauge data and derivative. The focus of this problem is the sea level change from 2004 to 2012, and Port Klang is chosen because it is a critical low-lying coastal port area where sea level rise can increase the risk of flooding and disrupt coastal infrastructure. The goal is to calculate the rate of sea level rise at the year 2010. To do that, we define the time variable t as year minus 2000. So for the year 2010, t equals 10. The data points we use are 2004 equals 6938 millimeters, 2008 equals 6966 millimeters, and 2012 7034 millimeters. Now, I will explain the calculation using derivative. First, we model sea level as function called s of t. Here, s of t represents sea level in millimeters and t represents time. Since sea level rise does not always increase at perfectly constant rate, we use a quadratic model. S of t equals at squared plus bt plus c. Lepas tu, next, we substitute the three data points into this equation to solve for this constant a, b, and c. After fitting the curve, we obtain the sea level function. S of t equals 1.25t squared minus 8t plus 6950. After we have the function, we apply derivative to find the instantaneous rate of change. The derivative is written as primes of t, which and can also be written as t s over dt. Now, we differentiate the function term by term. The derivative of 1.25t squared become 2.5t by using power rule. The derivative of minus 8t become minus 8, and the derivative of the constant 6950 becomes 0 by using constant rule. So we get s primes of t equals 2.5t minus 8. This derivative tells us the sea level rise rate in millimeters per year at any time t. To find the rate in the year 2010, we substitute t equals 10. And that's all from me. Thank you.
So, the location is at the Selangor Basin. This is the alternative water source from for the Klang Valley. So, we will go to the uh, integration calculation. So, as we can see, to find the cross selection area, which we will integrate the functions from the 30 minus 0.02 x and squared from the negative uh, squared from the negative 30 to the 30 meters. So the antiderivative is the 30x minus 0.02 cubed over the 3. We substituting the uppers and the lowest limit, and we get 720 minus negative 720. This give a total areas of uh, aquifers is 1440 squares per meter. Then we go to the justify and interpretation. So I have compared my manual step with the GPT's generate solution, and my justification is the AI calculate is accurate, and as the power rule of double negative substitution mesh with my manual verification perfectly. In a geoscience context, this area of 1,440 squares per meter is help the agencies like LUAS estimate the water reserve and this aquifer extend for 1 kilometers and it hold for 1.44 million cubic meters of water. These data are also critical to prevent the land subsidence and managing the water extraction and sustainability in the urban areas from uh, Klang Valley. So that's all from me. Thank you.
In conclusion, our case studies have shown how mathematics through derivatives and integration provides practical solution to geoscience challenges in Malaysia. From volcanic ash deposition, slope stability, and sea level rise to groundwater estimation, each example demonstrates how numbers can be transformed into insight and protect communities and guide sustainable development. My name is Putri Nurul Shahila binti Kamar Zaman, and on behalf of Group 5, we'll be signing off. Thank you.